Good morning, everyone. This morning I'm going to be very brief to consider a lot of problems. Okay. Good morning, ladies and gentlemen, viewers all over the world. Yeah, this morning we're looking at real analysis, and we are going to consider Taylor series. Already we have the problem here. Then we move further to consider Leibnitz formula to differentiate. Then I'm going to do a revision on calculus for those who want to know and learn more this morning. Is that clear? So stay tuned, like, subscribe, and share. Thank you and God bless you. Okay, here we have the problem. It says use Taylor's theorem with n equals to 2 to approximate cube root of 1 plus x. That is x is less than or equals greater than minus 1. Sorry. So this morning I'll be very brief on this question. Then I move to the Leibniz formula. Okay. Yeah. We have a very good question. So at first what we need to do is write a solution. Amen. So we have to convert this. We now say let f of x be equals to, let f of x be equals to cube root of 3 plus 1x. Then this is the same thing as indices. We have to apply indices 1 plus x open bracket raised to the power of 1 all over 3. Two of us. Look at the board very well. Look at the board. Somebody should look at the board. Look at the board very well. Yeah. So as you can see now, so what we need to do is we have to differentiate this function. It means our f of x equals to 1 plus x raised to the power of 1 all over 3, right? Then they said with n equals to what? Since it is Taylor's theorem, so it means we are just going to differentiate this function. How many times? Just 2 times. So how can we differentiate this function? As simple as ABC. Already you know that at least as it is now, we can use either substitution, right? We can use substitution method to differentiate this function. But we can, because of time, we can differentiate this method straight, direct. Is that clear? We use direct approach. It means our f of x prime, f prime of x will be equals to, what is there? 1 all over 3 to multiply whatever that is there. Amen? We have already invisible one here. So here will be 1 all over 3, open brackets, 1 plus x raised to the powers of 1 all over 3 minus 1, right? So far so good. So it means that you now come back to differentiate what is inside here, inside the bracket. So if you differentiate what is inside this bracket, 1 plus x. If you differentiate 1 plus x, you are going to have 1. So if you use 1 to multiply this, it's the same thing as this. So at the end of the day, this is what you are supposed to have. It means here will now be, if we have 1 all over 3 minus 1, then this is equals to 1 minus, take the LCM, 3 all over what? 3. Then this will be equals to minus 2 all over 3, right? So it implies that this will be equals to 1 all over 3, open bracket, 1 plus x, then raised to the powers of minus 2 all over 3. True or false? Then we have to, it means our f prime of x is equals to 1 all over 3, open bracket, 1 plus x raised to the powers of minus 2 all over 3. True or false? Do you agree with me? Then, since with n equals to what? So it means this is what we are going to do. We are going to differentiate this function twice. So it means our f prime of x now equals the same thing applicable. How you differentiated this one, you are going to apply the same thing. It means you differentiate this one. What is here? Minus 2 all over 3 to multiply 1 all over 3. So here will now be minus 2 all over, because 3 times 3, 9. I know some of you are confused. This is how it is. We have 1 all over 3 times minus 2 all over 3. Use 1 to multiply minus 2. We are going to have minus 2 all over 3 times 3, 9. True or false? Please take note. So we now come back. Hope you are following. Any question? You are following, right? Okay. Yeah. So far, so good. So what you need to do here is come back here to write what is inside there. 1 plus x, open bracket, raised to the powers of minus 2 all over 3 minus 1, since it is what? Differentiation. So here we are going to have minus 2 all over 3. Take the LCM. So if we take the LCM, we are going to have minus 2 minus 3 all over 3, right? All over 3, which is equal to minus 5 all over what? 3. So you are going to have minus 2, that is, you are going to have minus 5 all over 3. Then we come back to differentiate what is inside there. 1 plus x, 1. So 1 times minus 2 all over 9 is the same as minus 2 all over 9. Is that clear? So now, you know, the initial value x naught is always what? Is always equals to 0. And the Taylor's theorem. So if we substitute in 0 here, we are going to have if here is 0, we have f prime of 0, we are going to have what? 1 all over 3, open brackets, 1 plus 0, amen. Then raised to the powers of 2 all over 3. Then this is the same thing as I'll give you the same thing as 1 all over 3, right? Then our f prime of x equals to minus 2 all over here is 0, right? All over 9, open bracket 1 plus 0, this to the power of minus 5 all over 3. Do you agree with me? Yeah. So at the end of the day, this is what you are going to have, minus 2 all over 9. True or false? So if you can see what I am saying, it means we now assume f of x to be equals to p of x, p1 plus r, okay, is that p2, r2 of x. So it means our p2 is this 1 all over 3, r2 is minus 2 all over 3. So now let's record the Taylor series. The Taylor series will now our f of x. Our f of x now be equals to 1 plus this. That is 1 all over 3x, then minus our r2 minus 2x squared all over 9, then possibly plus constant r of x. Yeah. So this is how you are going to evaluate this type of problem in case you come across it. Any question? If you have any question, drop it in the comment section. Is that clear? Okay. So if there is no question, I'll move further. There's no question, let's proceed. Let me end this. Then move further to consider okay. Yeah, that's that. So let's move further to consider what we call Leibnitz formula. I know very well that some mathematicians, they don't use this or they don't teach this as long as differentiation is concerned. But you are supposed to understand this. It's simple as ABC. It is not difficult. How? First thing I want you to think of is, let's go back to our Pascal triangle, because it's helpful, very helpful. Pascal triangle is useful here. So if you can remember your Pascal triangle, I think it will do you good. Otherwise, you definitely have issues. So let us recall our Pascal triangle. Our Pascal triangle is, we can have a Pascal triangle 1, 1, 1, then 1 plus 1, 2, right? Then 2, 1, then we have 1 plus 1, 3, 1 plus 2, 3, right? Then 2 plus 1, 3, 1, again, 1, then Then we have it in this one, 1. Then 1 plus 3, 4, 3 plus 3, 6. 3 plus 1, 4. Then 1. So 1 plus 4, 5. 4 plus 6, 10. 4 plus 6 plus 4, right? 10. Then 4 plus 1, 5. 1. Okay, let's stop here. This is how to arrange Pascal theorem. We call this Pascal triangle, right? Yeah. So as long as Leibnitz formula is concerned, we need to make use of this Pascal triangle. Otherwise, you won't be able to make use of this formula to evaluate any function. Is that clear? Yeah. Then this will also remind us to product rule y is equals to what? uv. Is that clear? This will remind us to product rule y is equals to uv. If assuming you are asked to use Leibniz formula up to, let me say, fourth order to find a given, up to third order to find a given function, is simple as ABC. Is that clear? Please look at the board very well. Just look at the board very well. It is very simple as ABC. It is not difficult. Amen? It is not difficult. Yeah. So, far so good. As I was saying, I said here, assuming you are asked to say use as an example, use Leibniz formula to differentiate let us say y equals to 2x squared plus 1 times x cubed plus 1 up to fourth order. Amen. It's simple as ABC. Please look up. So when you come across questions like this, you don't need a prophet to tell you. I'm going to explain it for you to know and understand it better. Is that clear? Listen. Just look at the board. So as long as you are asked to use Leibniz formula, you must come back to what? Pascal triangle. It's very important. So, how are you going to use this Pascal triangle to evaluate this given question? Look at it. We know that as long as this function is concerned, we know very well that we are supposed to use product rule to evaluate this, two of us. Yeah. So what we need here is we need this formula. And this formula is in the form of what? Product rule. And they said up to what? Fourth order. It means what we need, the coefficient, we have to count from the Pascal triangle. 1 here, 2, 3, 4. It means what we need here is this. Can you see now? We just need 1, 4, 6, 4, 1. That is all we need. Do you understand? That is what we need. So what we are going to do here is we are going to use this. Is that clear? This UV. That is what we want to use. Look up. Look at it. Use this UV to multiply what is there. The coefficient there is 1. So it means here will be our y will now be equals to 1 times UV. This U will carry the highest order, which is the set forth. So here we are going to have IV, then this one will just remain multiply what? U. Plus, what do you have here? 4 times UV. Then, as U started with the highest order, V will now what? Increase gradually. Then U will now decrease in the derivative. So here we are going to have I. That is prime prime. U prime prime. Then V will be what? Prime, right? Then plus the same thing. After 4 we have 6. 6 times U prime prime. V prime prime. Then what we have here? 4 plus 4 times U will now be prime. Then V will now be prime, prime, prime. Then plus 1 times the same thing applicable, U, V, I, V. This is the Leibnitz formula we are talking about. Is that clear? Do you understand? Are you following? So now, it means this y will now be equals to, if you use this to multiply this, 1 times this is the same thing as U, I, V, V. Amen? Then, plus, the drop lights. Then, plus 4 times this is the same as 4 U prime 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 V prime. Then 6 times this is the same as 6 U prime prime V prime prime. Plus 4 times this is 4 U prime V prime prime prime. Then plus 1 times this is the same as U V I V. So this is the formula. Is that clear? But supposing they said up to third, assuming here is third order, what you need is this 1, 2, 3. So you just make use of these coefficients. Amen. Are you following? You just make use of these coefficients. So this implies that this will give you, if it is third order, it's going to give you y is equals to 1 times u. It means 1 dot u prime prime prime, that is third order, times v, plus 3 times u prime prime v prime, plus 3 times u prime v prime prime, plus 1 times u v prime prime prime. Can you see now? So this is what you are going to do. You have to first get the formula from using this Pascal triangle. Is that clear? So now we have the function here. The function is product rule you are going to use, two of us. And the product rule is of this form. So let us equate this and this. You don't need a prophet to tell you which one should be your u and which one should be your what? V. So now we now say let u be equals to 2x squared plus 1 and v be equals to x cubed plus what? 1. Do you understand? Are you following? Okay. Do you understand? Are you following? Look at the board very well. Everybody should look at the board. Just look at the board very well. So if you can see what I am saying, look at the board. It means here we have IV, that is your U. So it means you need to differentiate. We also have U prime prime prime. We have U prime prime. We have U prime. We have U. So what you need to do here is for us to differentiate U up to what? How many times? 4 times. So if we differentiate U up to 4 times with respect to x, it means we are going to have our U prime. We'll have, differentiate this, we'll have 4x. Here will be 0. Then U prime prime, differentiate this, we are going to have what? 4. Then U prime prime prime, we are going to have, if you differentiate this, to obtain U prime prime, you are going to have 0. And U IV, that is up to 4th time, you are still going to have 0, because if you differentiate 0, it will still give you 0. The same thing applicable to V. We differentiate this V. V prime is going to give us 3x squared. Here will be 0. Then V prime prime is going to give us what? 6x. Then V prime 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 is going to give us 6. Then V IV is equals to 0. Amen? Are you following? Do you understand what I'm trying to do? Yeah. So this is what you are going to do. Then at the end you are going to substitute in this value into this formula. Yeah. So what we do, we can clean this, right? Okay. So let's clean this. Let us clean this. And we can also clean here. Let us also clean it. So if you can see what I am saying here, you don't need the prophet to tell you. It means U IV is what? 0. So 0 times V. This is ordinary V. So this will be equals to 0 times the ordinary V is x cubed plus 1. Amen. Then what we have here? Plus. Amen. Then 4 times U prime prime prime. U prime 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 is 0. 4 times 0 times V prime. Where is V prime? V prime is 3x squared, right? Okay. Then where are we here? Plus 6 times U prime prime. U prime prime is 4 times 4. Then V prime prime. V prime prime is 6x. Then where are we here? Plus 4 times, amen, 4 times U prime. U prime is 4x, right? Look at it here. 4x. Then where are we? V prime prime prime. V prime 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 is 6. Then plus 1 times U. I ordinary u is this, is 2x squared plus 1. Then v iv is 0, right, times 0. So in all, if you use 0 to multiply this, you are going to have 0. 4 times 0, 0 times 3x squared, 0. So here we have 0 plus 0. Then 6 times 6x, 36x. 36x times 4. Here we are going to have 24 carry 2, 14, right? 4 times 3, 14 plus 2, 12 plus 2, 14. So 144, right? So 144x. So we are going to have 144x then plus here we are going to have the same thing, right? Yeah. No, not the same thing. This is 24x times 4 is 16 carry 1. 16x carry 1, right? Then times this 8, 9, right? 96x plus 1 times this is 2x squared plus 1 times 0. Here is 0. So at the end of the day, what we are going to have here is we can have this to give us this is what we are going to get, 144x plus 96, 12 plus x. So 144x plus 96x. Here we are going to have 10x, 10 carry what? 1. So this 15 plus 14 carry 1. So this 240x. So this is what we are going to have, 240x. So this is how you are going to use Leibniz formula to differentiate any given function. So should in case in calculus anywhere you find yourself and you were given question of this form, please, this is how you are going to do it. Any question before we continue with our revision briefly? Any question? Tamori, Robertson, yeah, good morning, how are you? Where are you watching from? Yeah, I know where you are watching from. Christopher, where are you watching from? Which country? Which country are you watching from? It's okay. So let's proceed further to continue with what I wanted to do. Okay. Yeah. So I can claim this, right? Okay, yeah. Let's consider revision of calculus. I was doing reanalysis assuming you are asked to, example, differentiate y equals to cos theta from first principle, as simple as ABC. Let's write solution. Amen. Write solution. Yeah, let us write solution. Look at the board. As simple as ABC. I'm going to break it down. Is that clear? Uganda. Oh, you are welcome. Robertson, you are watching from Uganda. You are welcome. Christopher from Nigeria, you are welcome. It's okay. We want to consider this simple problem in differentiation, right? How can we differentiate this function from first principle? Our y is equals to cos theta. Amen? Amen. Ordinarily, if we differentiate cos theta, we are supposed to have what? Our dy all over the x. We are supposed to have minus sine theta. True or false? That is true. Amen? Amen. Okay. Yeah. So now they say we should differentiate y cos theta from first principle. How can we differentiate this from first principle? That is what we want to look at. But one thing I have to tell you is you must take note of your trig functions. Yeah. Your trig functions. Very important. Very, very important. Do you understand? Look at the board very well. Just look at the board very well. Look at the board. You understand what I'm trying to say, talk about. You understand what I'm trying to say, talk about. Look at the board very well. Oh, we're taking the light again. Yeah, please, sir. Can you solve one question under Theorem on limits? Yeah, Christopher. Can we do that later? Can we do that later? I will drop my contact. You chat me up. I will do that later for you. I think I'm running out of time. It's because of you. I'll do that later for you. Is that clear? Okay. You can have my number. Write it down. 07033667737. For the fact that you are from Nigeria, you take it down. But foreigners plus 2347033667737. Just take note. Is that clear? Chat me up. I'm going to do that for you. Is that clear, Christopher? Just bear with me. It's okay. So I want us to take note of this. I want us to take note of this before we can solve this from first principle. Let's go back to our trig identity. Is that clear? As a mathematician, you're supposed to know your trig identity. You know that sine theta 1 plus theta 2 is equals to what? Is equals to cos theta 1 sine theta 2 plus sine theta 1 cos theta 2. True or false? Then likewise, cos theta 1 plus cos theta 2 is equals to cos theta 1 cos theta 2 minus sin theta 1 times sin theta 2. I want us to take note briefly on this. Otherwise, we won't be able to solve this from first principle. Is that clear? Yeah. Are you following? So let us solve this here. Let's solve this here. So if you can see what I am saying, let's come back with the formula. Y plus dy is equals to f of x plus dx. This is all in bracket. This is the formula for first principle. So far so good. So what we need to do here is we have to compare this cos and this. It means we are dealing with theta. So here will now be theta. No more x. Here too will be theta. Amen. Yeah, theta. So it implies that this will now be y plus dy is equals to cos open bracket theta plus d theta. So you can now see that this theta represents theta 1. Then this d theta represents theta 2. Amen? Amen. Okay. So if you agree with me, look at the box. If you agree with me, it means that we can proceed further. So we have to recall this. Can you see now? So it means we now write. Note that we go back to our trig identities. Our cos open bracket theta plus the theta is equals to cos theta times cos d theta minus sin theta times sin d theta. Amen? Amen. Okay. So it means instead of this, we are going to write this idiot. So here will now be y plus dy is equals to, instead of this, we'll write this cos theta cos d theta minus sin theta sin d theta. Amen. Then we subtract y from both sides. If we subtract y from both sides, we are going to have dy is equals to cos theta cos d theta minus sin theta sin d theta, right? Then minus, always put it inside the bracket, the y. Because supposing y is linear, definitely the minus supposed to affect what is inside the bracket after opening. Yeah, sorry for the break in transmission. Is the network. Sorry about that. Okay. So if you can see what I am saying, as you can see now, as I was saying, I said note that cos theta plus the theta is, we are using our trig identities. Cos theta cos the theta minus sin theta sin the theta. So it implies that y plus dy, instead of cos open bracket theta d theta, we are going to replace it with this. Look at it here. Then at this point, you subtract y from both sides. When you subtract y from both sides, you leave it inside the bracket. Supposing y is linear, by the time you open the bracket, this negative sign must affect the bracket. But if you put it, leave it like this, and y is affect what is first. And at the end of the day, you are going to arrive at the wrong answer. Okay, so we are going to have, it means the y is equal to cos theta cos the theta minus sin theta sin the theta. minus y, right? So what is your y? Y has been given us y equals to cos theta. True or false? Look at the board. Are you seeing what I am seeing? Amen? Okay. So if you can see what I am seeing, both in the spirit and physical, mathematically, amen, you don't need a prophet to tell you. So instead of y, we replace y with cos theta. Then here, we have d equals to cos theta, cos d theta, minus sin d theta, minus cos theta, amen. So they are like terms, this and this one. So what we need to do, we have to bring this one this side, take this one here, to, this is what I mean, amen. We have to write minus sin theta times sin d theta, and we have plus cos theta cos d theta minus, amen, minus cos theta. Yeah. So, oh, sorry, supposed to be dy. Let me clean it and rewrite it. Supposed to be our dy now be equals to minus sin theta times sin times cos d theta, then minus cos theta, amen, minus cos theta. Look at the board. Can you see what I am seeing? Yeah. So if you can see what I am seeing, it means at this point, what we need to do here will now be minus sin theta sin d theta. Will now, what is common here? Cos theta. You factor it out, cos theta, open bracket, cos d theta, here will be minus 1. True or false? By the time you use this one to multiply out this bracket, you still get back this idiot. True or false? Amen? Yeah. I love you guys. Okay. So, so far, so good. What we need to do here, we have to divide through by the theta. Divide through by the theta. So it means our dy all over the theta is equals to minus sin theta sin d theta all over the theta, then plus cos theta, open bracket, cos d theta minus 1 all over the theta. So far, so good. So at this point, what we need to do here is note that sin the theta all over